Alright guys, for today's lesson we're going to continue our discussion of the chain rule, but we're going to now expand it to the realms of derivatives of exponentials, so e to the x, and logarithm, so ln of x. So just to reiterate guys, the derivative of e to the x is just e to the x, and the derivative of ln of x is just 1 over x. Keep that in mind as we start looking at problems. Well, first thing that I want to do is let's look at logarithmic functions and taking derivatives of those. So say, for example, that I wanted you to find the derivative of the function ln of 2x. So notice I have 2x inside the ln of x function. So the derivative of that would be, take the derivative of the outside function, which is ln of x, so that would be 1 over, keep it in respect to 2x. Now go back and take the derivative of the inside function, and the derivative of 2x would just be 2, and then you could clean that up, and that would just simply give you 1 over x. So that's a very interesting problem. Let's say I want you to find the derivative of ln of x squared plus 1. And again, the derivative of ln of x squared plus 1 would just simply be 1 over function x squared plus 1 times the derivative of the inside function, which would be 2x. So that gives me 2x over x squared plus 1. Let's do one that has the product rule in it. So let's say I want you to find the derivative of x and ln of x. Ironically, this is not a chain rule problem, it's just a product rule problem. The derivative would just simply be x times first times derivative of the second plus second times derivative of the first, so that just gives me 1 plus ln of x. So chain rule, that was just the product rule for that one. Alright, the next one, let's say if I wanted you to find the derivative of ln of x, the quantity cube. So notice, there's a little play on right here. ln of x is the inside function and the 3 is the outside function. So its derivative would be 3 ln of x squared times the derivative of the inside function would be 1 over x. So that just gives me 3 ln of x squared over x. And that would be the answer for that one. Alright, now let's take it up a notch. Let's say I gave you the function. It was ln of the square root of x plus 1. Now, again, we have no rules for radicals for derivatives, so let's rewrite this. That would be ln of x plus 1 to the 1/2 power. Now, here's where some pre-calc is going to help you, because hopefully you remember one of the properties of logarithms is that exponents become the coefficients. So, I said that was the derivative. That is not the derivative. That's just the function rewritten. So what I was saying was, again, I'm not going to do no calculus just yet. I'm just going to rewrite this as 1/2 ln of x plus 1. So again, if you're watching the video, this is not misleading. I did not take the derivative. Just used a property of logarithms which says that exponents become the coefficients. And I just rewrote it as this, because now I can take the derivative of this function very easily. The derivative of this function would simply be 1/2 still out in front. The derivative of ln of x plus 1 would be 1 over x plus 1, and then take the derivative of the inside function, which would just be 1. And so that cleans up, and that gives me 1 over 2 times x plus 1. And that would be the derivative of ln of x plus 1, square root of x plus 1. Let's take a look at one more of these. So let's say I have the function, and it is ln of x times x squared plus 1 squared over the square root of 2x cubed minus 1. And again, we have no rules for the derivatives of radicals. What I'm going to do first is I'm going to rewrite this. So I'm going to say that this function is the same thing as ln of it'd be good to maybe put a bracket. So ln of x times x squared plus 1 squared. And then in parentheses, this would be 2x cubed minus 1, and that would be to the negative 1/2 power. And so now what I'm going to do is I'm going to use my pre-calc properties of logarithms to expand this logarithm, because could you imagine how to take the derivative of this? That's a huge chain rule function composition, this function inside of that function. So I'm just going to rewrite this using a pre-calc topic. So I'd say this is ln of x plus 2 ln of x squared plus 1. Notice what I did there. You see, property of exponent, this exponent becomes the coefficient. That's why I'm going to have minus 1/2 ln of 2x cubed minus 1, which this is a lot more easier to take the derivative of, because I can take the derivative one piece at a time. The derivative of ln of x would simply be 1 over x, plus the derivative of this would simply be 1 over x squared plus 1, so derivative of x squared plus 1 times the derivative of the inside would be 2x, and this would be minus 1/2, and the derivative of this would be 1 over 2x cubed minus 1 times the derivative of the inside function, that would be 6x squared. So if I clean this up, let me do it in blue, get 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. And that would be derivative of that function. So again, pre-calculus definitely comes in handy. Right, so now let's take a look at some exponentials, right? So let's do some derivatives of exponential functions. So let's take a look at this next one. Let's say that I gave you the function e to the 2x minus 1, and I wanted you to find its derivative. Again, you notice this is a chain rule because I have a function inside of another function. So the derivative of this would be the 2x minus 1 is inside of the e function. So the e function is my outer function. So the derivative of the outside would be e to the 2x minus 1. I like these, just 2x minus 1. Go back and take the derivative of the inside function will be 2. So that just gives me 2e to the 2x minus 1. If I give you another one, let's say I want you to find the derivative of the function e to the negative 3 over x. Again, the derivative of that would just simply be e to the negative 3 over x. And then take the derivative of the inside function, which, be very careful, the derivative of negative 3 over x, you don't have to use the quotient rule for that. Just remember that negative 3 over x is the same thing as negative 3 x to the negative 1. So its derivative would be positive 3x to the negative 2. So that would just be positive 3x to the negative 2. And so that would make my derivative 3x to the negative 2 e to the negative 3x. And of course you can clean that up. I'm not going to. All right, last one. Let's say I just gave you the function x e to the x. This is not the chain rule. This is just the product rule, but I just want to bring it home for you really quickly. This would simply be the derivative would be first times derivative of the second plus second times derivative of the first, which just gives me x e to the x plus e to the x, which technically is the same thing as e to the x times x plus 1. And then that would be the derivative for that. That's it for today's lesson.